Fifth thing, the fifth component, admixtures. Again, most people treat this separately, but I'll throw it in as a component of concrete. Just because, I mean, in this day and age, admixtures are so popular and so widely used that, you know, to tell you the truth, I think probably, at least in the commercial world, you would be more likely to see a mix with admixtures in it than you will ever seeing a mix that's just plain. Okay? Admixtures are used that often in the commercial world. Admixtures, we're talking about a chemical or a mineral. You can talk, there's mineral admixtures too. But, I mean, typically we're talking about something that's going to be placed into concrete to give it some property, some characteristic that we are going to find beneficial. It's going to do something for us. There's no reason to add stuff in if it doesn't do something for us. So, anyway, we've already talked about one admixture. We talked about air entrainers. That's a broad type of admixture. Okay? There's other broad types. There's admixtures that we call or act as accelerators. Okay, what do you think an accelerator would be?
Something to speed up the process and make it harder.
Yeah, speeds up the process of gaining strength, making it hard, things like that. So an accelerator. Probably use an accelerator, maybe one common place to use it is maybe when we have colder weather. Because if we can accelerate the strength gain, then we don't have to protect the concrete that long. Or maybe we use an accelerator to break concrete out of its forms quicker. Okay? I mean, they use accelerators on precasting plants and precasting plants all the time. You know, because they want to break their beams and whatnot out after a day or two. They really want to move it along. So, the flip side of that, we've got a class, you know, of certain admixtures that people will refer to them as retarders. A retarder would just be sort of the flip side of the accelerator. You know, something that you can put in concrete to slow the reaction down. Okay? We slow the reaction down. Hey, you know, it gives us more time. All right? What would be probably a key place that you'd want to use a retarder in concrete? Or, huh?
It's hot.
If it's hot out, yeah. If it's hot out, you know, using a retarder would help you because it slows stuff down. All right? There's a big class. It's called water reducers, and besides this, some people might refer to this class or generally in this same area as plasticizers. In the really narrow definition, a water reducer is a chemical that you can add into concrete, and by adding the chemical we can reduce the amount of water that we put in it, but it keeps you know, the concrete acting the same. So we could add a cupful of water reducer, but we might be able to reduce the amount of water by 30 pounds every cubic yard. That's a good trade-off. Because less water means what? More strength, and there's other stuff that goes along with it. But we're keeping the same workability, so hey, that's a good deal. If I don't use it that way, and I keep the amount of water the same, but I add my chemical in there, what's going to happen? It's going to make it more plastic. It's going to make it more fluid. They call it, when they use it like that, they call it a plasticizer. So I could take a dry mix of concrete, keep the water level the same, add a cup full of this in there, and all of a sudden it looks real liquidy for a period of time. All right? So it's the same. We're using. I mean, there's 100 different chemicals we can use, but they work in similar fashions. I mean, what they actually do is they create sort of a coating around the cement particles, the paste that's electrically charged, and they won't let them come together and flocculate together. But so we can use it a couple ways. We can actually use it to reduce the water. That's good. Or we can keep the water level the same, add it in, and it makes it act like it's much more liquidy, like it has a much more water in it. Okay? So that's a very popular one. So because it does so much for us. Okay? So those are the basic categories. Now again, you can get to an admixture company and they could have, you could go to W.R. Grace. They might have 25 products that they're calling water reducers or plasticides. I mean, this is what they do. They make a lot of this stuff, but it's not like they're just going to see one. They're going to, hey, here's a low-range water reducer. Here's a mid-range water reducer. Here's a high-range water reducer. Here's a mid-range water reducer that also acts as a retarder. Here's one that also acts as an accelerator. Blah. They've got a lot of them. So, I mean, this is an area that's really exploded. There's other stuff. These are the main ones, main areas that you could have. But there's admixtures that they call corrosion inhibitors. That again to help stop steel from corroding, rusting. We'll talk about that in a little bit. There's a bunch of other ones, but they're sort of minor. The one that I would throw in here when you talk, these are all chemical admixtures. People will talk about mineral admixtures. If they're talking about those, a lot of times they'll use another name for them. And the other name for like mineral admixtures would be pozzolans. And a pozzolon is something, again, a lot of people call it mineral admixtures, that is basically more or less a garbage product. But it's a product that they found that they can put into the concrete, and it goes through a secondary cementitious process. We said how cement and water went through this process called hydration, and that's what makes the concrete hard. We'll talk more about that here in a few minutes. But a pozzolanic material is a material they can throw in, and while it doesn't react with water, it reacts with the reaction that cement and water are going through to give it new properties. Maybe make it stronger, maybe make it more impermeable. So there's several of these that are out there that are fairly popular that are called pozzolanic materials, or some people call them mineral admixtures. One is referred as fly ash. Fly ash is a mineral admixture that you can put into concrete. You can actually you can use a certain percentage of this to replace a certain amount of the cement. So you can actually use these as sort of like, hey, instead of using 100% cement, maybe I'll use 80% cement and 20% fly ash, let's say. And they can even go higher with fly ash than that. Fly ash comes in a couple different categories, but we won't get into that. You know what fly ash is? Where does it come from? Coal burning power plants. The stuff that goes up through the smokestacks that they capture now. In the old days they didn't capture. They do capture nowadays. They capture all this dust going up. They scrub it out. They collect it. That's fly ash. All right? What do they do with fly ash? Well, generally what they do is they go to some rural area and whatever state you're in, buy a bunch of land, dig a big hole, stick it in the hole. All right? Some people have problems with that. So if they can get rid of fly ash, then other means, like hey, putting it in concrete, all the better. You know? And if you pay attention, you will, every once in a while you'll hear a big mess that fly ash makes. There was one that was maybe 2 years ago down in Tennessee, where a big fly ash lagoon broke and 5 million cubic yards of fly ash comes flowing down through this valley, literally wipes out, a little town and whatnot. It's sort of like a flood of fly ash. So it's down in Tennessee. I want to say the Kingston Valley Power Plant or something. Look it up. I mean, it's pretty big mess. But that's why people don't, they're a little bit hesitant about, well, they do it. I mean, the power companies buy land, they build these lagoons, but if these lagoons fail, it can be a catastrophe. So anyway, so if we could put it in concrete, hey, great, That's fly ash. Another common one's called silica fume or microsilica. This is the gold standard. Microsilica comes from the production of silicon plating, and it's the gold standard because they've really found this to work very well. It's an extremely fine particle. Portland cement, I mean, those of you that know Portland cement, you'll see Portland cement when we get in the lab, that's a very fine powder. Silica fume is 20 times or more finer than that, 10, 20 times more finer. I mean, it's it's on the same level as smoke. I mean, that's how fine this particle is. It works out very well when you put it in concrete. It makes the concrete extremely strong. It really helps the hydration process, makes it very impermeable. So silica fume, this type of concrete, is, I mean, if we're going to produce high strength concrete in this area, we'll be using that, How much cement can you replace with it? Maybe about 10%, okay? The thing about silica fume, though, it's expensive. I mean, you're probably going to add $50 a cubic yard to your concrete cost. So you'll add, let's say, 30 to 50% on your cost because it's that good. What else? Could they use blast furnace slag in the steel manufacturing process, the iron manufacturing process? There's residue that we draw off called slag. It's the stuff that floats to the top. You draw off. It's the impurities. We can grind that up. That works. There's been a lot of stuff, concrete made with slag as sort of a cement replacement. There's other stuff. You know what all these things have in common? They're all high in silica. They're all very high in silica. So that's what they all are. There's another one that people work with as a garbage product, and this might even be environmentally friendly, is ground up glass. Glass is high in silica, but it's a little bit hard to work with, trying to put shards of glass in concrete. Really, it's not hard to work with. What they found is it's very hard to regulate, okay? Because we need this stuff to act appropriately, and glass sometimes doesn't act appropriately.